Let's learn about the area of trapezoids. Now, one thing, I'm going to just do a quick sketch in here about the area of trapezoids that I would urge you to think about, at least before you kind of become familiar with the formula, is that we try to connect any trapezoid back to a rectangle. And how we do that is basically by looking at the two kind of bases that we have. And the bases, by the way, are always the parallel sides. So the bases are here, but over here, these are the bases, or at least the best I could do drawing them, okay? The bases are the parallel sides. What we try to do is almost think about, well, what if we could almost like split the difference in the lengths of our two bases? So, we say, okay, well, this base, that long. What if we kind of came in the middle like this and drew a height here, like that? And then we said, well, this entire thing would be the base of a rectangle, and here's the height. And then we could do it like the base times height, the area of a rectangle. If we could kind of average those two trapezoid bases and think about it almost making a rectangle. And you could also think about taking this and almost flipping it up into here, that this part of the triangle I cut off would fit perfectly in here, and that would be the whole area. Well, the way we do that is mathematically we just find the average, the mean of the two bases, and then we multiply by the height. So let's think about how we would do that. To find the average of two things, we add them up. I'm going to write base 1 and base 2, and we would divide that by 2. That would be the average of our two bases. And then if that serves as our kind of imaginary base of a rectangle, then we multiply that by the height. And that's the area of a trapezoid. Now, most often you'll see the formula written a little bit differently. You'll see it written as 1/2 base 1 plus base 2 times the height. But notice those are exactly the same thing, because in both of those cases, you add up the two bases and then find half of it. Let's do an example. All right, so here you can see our two bases are 9 and 13. Again, look for the parallel sides. Sometimes, you might have a triangle oriented differently or rotated. The bases are always the sides that were parallel to one another. So I'm going to use my formula. I'm going to use that second one because that's what most textbooks will use. Just kind of plugging in. So we say, all right, 9 plus 13 is 22. Half of 22 is 11, and 11 times 8 is 88. Again, what this accomplishes, this part, this 1/2, 9 plus 13, it finds almost an average base length. So it kind of comes out here to like 11 units in and says, I'm just going to draw a rectangle like that. So this finds that average base, and then we multiply by the height. Let's do another example. All right, I'm using my other kind of strangely oriented trapezoid. So notice the two parallel sides are 10 and 18, and the height, much like parallelograms or triangles, has to be something that meets the base at a right angle, so the height is 5. So using our formula, the area is going to be 1/2 base 1 plus base 2 multiplied by the height. So I think about 10 plus 18 is 28. Half of 28 is 14. And 14 multiplied by 5 is 70. Let's do one more example. Let's say we had to solve for one of the missing pieces. Let's say we knew what the height was and we knew one of the bases and we knew the area, but we don't know the second base. Well, let's use our formula. So we know that 55, the area, is going to be equal to 1/2 base 1 plus base 2 multiplied by 5, the height. Now, you have a lot of different choices here. For example, you could say, well, I'm just going to divide everything over a piece at a time. I'll divide both sides by 5. Then I'll multiply both sides by 2. You could distribute the 1/2 in. You could say, well, it's 1/2 x plus 7. And then you could distribute the 5 in. to both. You could multiply the 1/2 and the 5 together because they're both outside the parentheses and divide. There are lots of different ways you can do this. I think I'm going to kind of distribute everything in. That'll be my method on this one. Probably my more preferred method would be to just divide both sides by the two numbers that are outside the parentheses. But I'm going to distribute, okay? So I'm going to start with the 1/2. So I'm going to have 1/2 x plus 7, and I still have that times 5. Well, then let's distribute the 5 in. So I'd have 5/2 x plus 35. And now it just looks like an old-fashioned algebra problem. Subtract 35 from both sides. So you say, well, 20 equals 5/2 x. Let me kind of scooch up here where I have a little more room. 20 equals 5/2 x. Divide both sides by 5/2. That's the same as multiplying by 2/5. So 2 times 20 is 40. Divided by 5, x is 8. Okay. Again, lots of ways we could have handled this problem. You could have started by dividing the 5, so you'd have 11 equals 1/2, and then multiplying by 2, so you'd have 22 equals x plus 14. And that's probably the way I would handle this normally. But either way, you'll get the same answer using a little algebra. If this video helped you, please like and subscribe for more math help. I have an entire playlist dedicated to geometry.